All right, let's continue from where we stopped. There is a question written here from Iram. Is it valid, Iram, or did I explain it already, or do you want me to go over it again? Because I don't know when it appeared in the chat. Iram, are you with us? Yes, Hocam, thank you. I answered that. All right. Okay. Then let's go over quickly and then solve the example with it. We were discussing what happens if we add a new variable. And I said primal feasibility can never be lost because we may always say, even though there is a new variable, I'm not producing that. So the value of that can always be set to 0, which will leave me to feasible, which would say that my current optimal solution will remain feasible, but it may not remain optimal. So you check if it is still optimal or not by checking the criteria by checking the dual feasibility with respect to this new variable, right? Because for a new variable, for each variable, we have a constraint in the dual anyway. So all we need to check is if that means when I introduce a new variable for my primal, I'm actually introducing a new constraint for my dual. So is my dual still feasible? I may lose dual feasibility because I may lose primal optimality. So all you check is actually dual feasibility, which is the row 0 entry of that variable. You just check if the constraint for that variable remains valid or not. You check if it is still non-negative, that means your dual also remains feasible. Even though I have a new variable, it doesn't pay off. I'm not producing, my current solution remains optimal. If not, if it is more profitable, then the row 0 entry for that variable would be minus negative. So I'm supposed to produce that. How do we do that? Of course, you have to add B inverse A7. Right? Because you have to add that new variable to the current table. How do you do that? With B inverse A and minus C plus CB B inverse A, right? That's what you're supposed to do. For example, if there is a new X7 consumption method, taking one from each resource and the objective function coefficient is 15, you just check if the dual feasibility is intact, and it is. With this values, even though, did I put it in here? No, my current solution is remaining optimal. I'm not producing that because the row 0 entry for that variable would remain non-negative. Yeah, I think we have a different one. Yeah, what happens if C7 was different? So it's still, so what happens if I produce a new variable, A7 with 111 and C7 25? All right, you do this, you check. It is not, current solution is no longer optimal, right? So you have to do B inverse A7, put it in here. This is B inverse A7. This is minus C plus CB B inverse A7. It is negative. So X7 will enter. You do the ratio test. X1 will leave. And then you apply your normal simplex iteration. Okay? So adding a new variable, if row 0 coefficient remains positive, nothing changes. If not, apply primal simplex. Okay, how about if I add a new constraint? First of all, okay, I have my solution X star, which was optimal with respect to my current setting. Then all of a sudden, production department this time says, you know what, there's another constraint that you just forgot. So first of all, can I safely say that, well, I don't care, my primal feasibility will remain valid or not? Can I say that? Primal feasibility is not affected? Can I? No, thank you very much. I cannot, of course, because I'm adding a new constraint. So as you just see in this picture here, so say these were my constraints and this was my optimal solution. And all of a sudden, another constraint is popping up. If this new constraint is something like this, my current solution is no longer feasible. If the new constraint is something like, I don't know, that, it will not affect. But I can't safely say that feasibility is intact. No, it may change. How about optimality? If the solution remains feasible, can I say that it is still optimal? Why not? If you have an answer, write to me privately, please, this time. Because this is a nice question. It's a very good true-false question for an exam. So I would like to know your response for this. So write to me privately. I don't want everyone else seeing that. But let me repeat the question. Now, we have discussed that primal feasibility we may lose feasibility. Let's say the solution remains feasible. What can I say? Can it be not optimal? Come on, I want more answers privately. I only got 2 up until now. Write to me. I'm waiting. Just say yes or no. I'll explain. You don't need to write. So if I'm remaining feasible, but my question was, will I lose optimality? May I lose optimality? Mm-hmm. Now, most of you actually answered wrongly, but anyone else wants to go on? I'll stop right now. Okay, I stop. No more answers, please, because I'll explain. Now, look at here. Look at this picture here. I have 2 different options, a red constraint and a purple one. My current optimal solution was this orange thingy here, all right? Now, I'm adding the red constraint. I'm no longer feasible. Okay, God, I can't even talk about optimality. I'm not feasible anyway, right? Okay, how about the purple constraint? I'm adding the purple constraint, all right? Then my current optimal solution is still feasible. Now, think about it. It was an optimal solution for a relaxed problem. It is still feasible. Of course, it will remain optimal. What else would you find? Whatever your improving direction was, it was going that way. And it is still okay. It's still in the region. Now, I added the purple one, right? So these are the 2 additional extreme points that may challenge the optimality of my current optimal solution. But you know what? Before the purple constraint, those points were already feasible, but my current optimal solution beat them anyway, right? I mean, these points were already feasible in my original problem, but I didn't declare them as optimal. I declared this one as optimal, right? So once I put another constraint in, if my current solution is feasible, it will remain optimal because it was optimal in the previous case, which had a larger feasible region. I shrink my region now. I may lose the point, like happening in the red constraint. The guy is no longer feasible, so there will be someone else optimal this time, right? But if it is still feasible, whatever other things going on, it will be the winning point all the time, right? Any questions here, or is it? I mean, the answer was already here, by the way. Current solution is still optimal. Is it clear? Because I really like this type of discussions, and if you don't get it, please ask me. Okay, so let me come back to sensitivity analysis. Now I'm adding a new constraint. This new constraint then may affect my primal feasibility, as we have just seen. I may no longer be feasible. Okay, you want somebody asks me to repeat. Thank you, Rana. Let me explain then again. I like to go over this colorful point. Again, I have 2 options. Now, if we lose feasibility, there is no question there, right? If we lose feasibility, we may never think about optimality anyway. Fine, gone. for the case when we don't lose feasibility. So let me draw again. Or, let's go in here. When I add this purple line, yeah, where's my purples? Oopsie. Anyway, when I add this purple, hold on, sorry. Yeah, when I add this purple line, okay, my current feasible solution, current optimal solution is still feasible because this was my region at the beginning. This was my region, yeah, and I'm adding this purple thingy right now, okay? My current optimal solution is there, still feasible. Now, in order for this thingy to lose optimality, some other corner point must challenge him, right? Now, the new corner points that are coming into picture are this one and that one with this new constraint. The other ones were already with me when I was solving the original problem, the problem over the green space. When I was solving it, there were 1, 2, 3, 4, 5 corner points, and this one win among those 5. Right? Okay. I put the new constraint, purple. My problem is still, my current solution is still in the feasible region with the new constraint. What else am I getting now? I get this point and this point as additional corner points who may challenge the optimality of this guy. Well, can they? This point was not even a corner point. It was just another feasible point in my previous solution, right? It was there. That's actually, if this was optimal in my previous case, these will also be optimal too. Look at this guy. Again, it was feasible in the previous case. Why and it didn't challenge. Now, my objective function is still the same. My improving direction is still the same. So in order to have this point as optimal, apparently I'm leaving the region something like that. Okay? In that case, well, my current optimal solution actually beat these guys in the previous case anyway. They cannot challenge my current solution's optimality now. So if I remain feasible, I will never lose optimality. Could it affect the type of solution? For instance, can it change from unique solution to alternate solution? Well, I don't know. It depends on the constraint you're doing. It was unique and now you want it to be alternate. In order for this guy to be alternate, I don't know, maybe. I can't think about it like Ram. Okay, you're welcome, Rana. I don't have an answer for that, Iram, right now. But you might also think about a nice picture for this and well, maybe it was alternate, now it's unique. That happens, that can happen, depending on the constraint. I can think about it immediately. But it was unique, can it be alternative? I don't know. I need to think about it a little bit more, all right? Then, let's go back to sensitivity analysis. Now, I'm adding a new constraint. I may lose feasibility. Okay. If I don't lose feasibility, yeah, it can be unique when it was alternate. I guess so. Depending, because say this, for example, like this was optimal, and then all of a sudden I got this constraint like this. So the rest are no longer feasible, but only one point become the optimal solution. So yes, if it was alternate, it can become unique. But I can't think about unique from going unique to alternate. I don't know. In order to, let's say this was thing and this was my optimal solution. Now you're adding a constraint such that this one becomes one of the alternative optimum solutions. I don't know yet. Maybe it's not easy to see. Yeah, that's what I'm thinking, from unique to alternate. I really don't know. I can't come up with an answer for this right now, but I'll think about it, all right? And if you guys can come up with something, share your screen or draw it and send it to me. If this was unique, I'm going to add the constraints so that it will become one of the alternative optimum solutions.
Hocam,
Ay, bir korktum ki. Şöyle.
Bu y line üzerindeki y'nin ve tarif edemedim. Şu an şey var ya, y üzerinde kestiği eksen var ya, şu an çizdiğimiz line.
Şu eksen, evet. Tamam.
Yes. Y'yi kestiği nokta mesela unique solution olsaydı Evet.
Okay.
Oradan x'e paralel bir yeni constraint ekleseydik.
All right. Hold on. Let me change my color. So this is your new constraint.
Evet. Ve mesela objectivimizde maximize y olsaydı şimdi alternate oldu.
If objectives was maximize y, then this would be my optimum solution, not this one. But for this to be my optimum solution, I have to leave the region like this. So, well, the answer is not that clear. So we need to think, but thanks for trying. Thanks for trying. Let's think about this, all right? It doesn't come to me right now. It was unique and it's going to become alternative from unique to alternate. Let's think about this a little. Let me finish what I'm doing, all right? Because I want to be done with sensitivity analysis today. But this is a nice thingy to think about. All right, let me go back. So again, if it remains feasible, it will remain optimal. If not, that means I lose primal feasibility. That means I have to use dual simplex because I didn't do anything in my dual feasibility. I didn't change the dual feasibility. CBB inverting is still intact, right? Adding a new constraint to primal is actually meaning that I'm adding a new variable to the dual. In the previous case, this new variable value could be 0 and affect the feasibility of the dual, right? So dual feasibility is intact, but we may lose primal feasibility. And that means we have to use dual simplex if we lose primal feasibility. If we don't lose primal feasibility, life is fine. Nothing changes. The current solution with the current value remains optimal, all right? If we lose primal feasibility, that means we have to update our table. But this is a new variable, right? So that means we have to have, okay, this was what we already had. We need to have another constraint or another row in here, yeah? That means our dimension is increased. The dimension of B, I need a 1 and zeros elsewhere for this one too, right? So usually that comes with an artificial variable. We have to be careful in updating the table and continuing if we lose primal feasibility, all right? We need to add constraint as a new row. Okay, this is the procedure to follow, by the way. This row should have a basic variable. It may, now if the constraint is less than or equal to type, it will have its own slack anyway. So we're fine. But if it is not, I may need additional artificials. Put the table in the proper format because this new thingy should be 1000, yeah? And then apply dual simplex. Be very careful. Don't immediately go to dual simplex. You have to have a legitimate simplex table to go with, which actually requires certain column row thingies before you go on. I think we have an example. Yeah. What happens if we introduce this? X1 plus X2 or 3 greater than or equal to 9. 3. Okay. Now my current solution is this. Yeah. So check. Is it still feasible? Yes. The constraint I just added is like the purple thingy here. It's not affecting my feasibility. If I remain feasible, I will remain optimal anyway. So I'm still optimal. I don't need to do anything. Nothing changes. B inverse B is the same. CB inverse B is the same. My current X star, which is this, is still optimum with objective function value 280. Fine. How about the reverse then? If I introduce this constraint, you just check. No, it's not feasible anymore. So it cannot, no longer feasible. Yeah? So you need to update feasibility, update your table, and add this guy, this new constraint to your table. How do we do that? First of all, I have to have equality in the simplex. So if the constraint you're checking is not equality, you have to convert it to equality at the beginning. So my new constraint is x1 plus x3 plus x7 equals to 9. Even though I'm adding a new constraint, I'm also adding a new variable, which is the slack of this new constraint. Well, I need that anyway because I need a basis representer for that constraint. So here is the table, with the original constraint. Then be careful, update the table so that the basis, the constraints, the coefficients in the basis, right? So I need to have a 0 in here, and I need to have a 0 in there because those are my basic variables. I'm not allowed to have non-zero entries in those columns other than the representative constraints, right? So I'm supposed to do the row operation so that this is a 0, this is a 0, so that I have a legitimate table. When you do that, this is your new row for x7, okay? So this is no longer valid, but this is valid. Okay, and this has a -1, which means I'm no longer feasible. Apply dual simplex. I want to get rid of x7. Now, who can enter? The ratio test is valid for the negative entries. There is only one. So this guy will enter to my basis, which is x5, and x7 will leave. When you do one dual simplex iteration, you're going to get to this solution, which is now feasible and out. Clear? Any questions? Any questions? Okay. Don't forget to update the table. This is a new constraint. When you add the new constraint, you have to make sure that B inverse A is B inverse A, right? So this new thing should be zeros under the identity columns for the basic variables. That's what we did in here, all right? Okay, how about we introduce x1 plus x7 greater than or equal to 11? It's not x7, x3. In my current solution, doesn't set, so another type, okay? The previous one was a less than or equal to type constraint. Now I'm adding a greater than or equal to type constraint. How about I need? Any questions? All right. I'm adding a new constraint. Again, my current solution is no longer feasible. It doesn't satisfy this constraint. So I have to add this constraint to my table. But first of all, I have to convert this to equality. So my constraint is x1 plus x3 minus x7 equals 11. Yeah? Now I'm going to add this. But since I need a 1 in here, I add this constraint as minus x1 minus x3 minus 11, so that this becomes a +1. I'm going to apply dual simplex anyway, so it's okay to have minus things in the right-hand side. I know that's going to happen, so at least I will have a basic variable for this new constraint, which is x7. But even with that, I still need to have 0 in here and 0 in there because those are corresponding to my other basic variables, those coefficients. So I cannot have non-zero entries in their column. Do the thingy. This one is no longer valid. My new row for x7 is this. Okay? I'm kicking x7 out of the basis. This time I have two options to enter, either x2 or x6. Due to the ratio test, x6 enters, and you go. It's not only one, but there are actually more than one iteration. So I stopped. It's still simplex anyway, which was last week's topic, Monday's topic. Okay. So if you add a constraint, you check feasibility. If you lose feasibility, you're supposed to add that constraint to your simplex table. That constraint should come to the simplex table in the equality form and should have a basic variable representing that constraint, okay? That means I need to have a new variable for this constraint, which is 0 elsewhere and only 1 for this constraint. If it is a slack variable, life is easier. If it's an excess variable, it doesn't matter again this time because I know I'm going to have a negative entry anyway. So if it was an excess variable, you just multiply the constraint with -1 and then add it to the table. then do the other operations too, so that this table becomes a legit one. So if it's a less than or equal to or greater than or equal to, the slack or the excess will actually work for my table. And you do the rest. If the constraint is equality, there is no slack, there is no excess. What we suggest here is replace that equality with less than or equal to and greater than or equal to, and add them to your table. So that means we have two additional constraints, one with a slack, the other one with an excess, but it's negative right-hand side. Apply dual simplex. I know how to deal with those and go with it. Any questions? I have a quick summary for sensitivity analysis, so I'll go over the material once again when we're doing this. So be careful. It's always handy to have the matrix notation next to me. So let me do that again. All right. B inverse A, B inverse B, minus C plus CB, B inverse A, CB, B inverse B. All right. Now let's see if B changes. If the right-hand side B, little b, changes, what happens? You just see B appears in here and right-hand side only. So row 0 is intact. Primal feasibility may be lost. Current basis is still optimal if right-hand side is still non-negative. If not, you're supposed to apply dual simplex. Be careful. If current basis is still optimal, you still need to say X star is B inverse B tilde. You need to update the value of X star and your Z star, which is CB B inverse B, with the new B. Even if your basis remains optimal, you have to update your optimal solution with respect to the new B tilde. Okay? If with your current solution is no longer feasible, that means you have negative right-hand side there, so you apply dual simplex. Okay. Changes in the objective function coefficients. For non-basic variable, only one entry in row 0 is changing. You just see if that entry is still valid or not, non-zero or not. If the non-basic variable's coefficients, row 0, became negative, that means that variable wants to enter to the basis with the new cost coefficient, objective function coefficient. So you apply standard simplex. If not, if the current solution is still feasible, if row 0 is still non-zero, nothing. Yeah? So we're losing dual feasibility. We may be losing dual feasibility because of the row 0 coefficient of this change. This is current basis remains optimal if this is true. If not, xk will enter via standard simplex. For a basic variable, all row 0 is changing. You have to reconstruct row 0 and see who wants to enter or not. If still everybody is non-negative, you're still fine. If somebody wants to enter, you enter whoever has the most negative entry. Do not forget to update your CB inverse B value even if your current solution is still optimal. Okay? Changes in A was, again, we differentiate between basic variables and non-basic variables. For non-basic variables, you just check the dual feasibility corresponding to that constraint again. And if dual feasibility remains intact, nothing changes. If dual feasibility is lost, then that variable wants to enter to the basis, you apply primal simplex because nothing changes in the primal feasibility for a non-basic variable's consumption vector. But if that thingy is basic, then your B is changed, capital B is changed. That means the whole table is changing. current basis is still optimal if B inverse B and CB B inverse A minus C are all non-negative. It's a very rare situation. Usually complications may occur, so you have to be careful with the complications if the A that you're changing is corresponding to a basic variable, right? You have to check is B inverse is still, if B is still invertible, so if the columns of B are still linearly independent, and even if then you have to check if row 0 and right-hand side still non-negative, then you can do whatever simplex is appropriate. We also discussed adding a new variable and a new constraint. If we're adding a new variable to the primal, we may never lose primal feasibility, but we may lose dual feasibility because we may lose primal's optimality. So the effect is in the dual domain, dual feasibility. You check if the dual is still feasible. If not, then apply simplex because the new variable wants to enter to the basis. If I'm adding a new constraint, I may lose primal feasibility. That means if the solution satisfies the new constraint, you don't need to do anything. If the solution does not, then you have to add it to the simplex, convert the table to the legitimate format, and then apply dual simplex. Yep, this is the last slide. Any questions? Okay. Then see you this Saturday at 4:00 for the quiz on duality. All right? Good luck. Goodbye. Have fun.
The quiz is only going to be on duality, right? That being set number 6 and set
that
number
we
5.
Discussed last practice session. Yeah, dual simplex and sensitivity is not in this quiz. It will be in the next quiz.
Okay.
Which I already registered, by the way. Be careful. I put all the quizzes to your SRS system. Via exam scheduling. Only this one is on Saturday. The rest will be in one of the class sessions. Just check from there and be in class because we will have quizzes at certain classes which are already announced in your system. You should be able to see them right now. I did that yesterday.